Webinar on skimmer basin design for construction and post-construction water quality. Forgot to mention one housekeeping item. If please make sure you're muted just so everyone can hear. But if you would like to ask a question, please feel free to unmute yourself and ask that, or you're welcome to use the chat box to type in a question as well. So like I said, my name's Jamie McCutcheon. I am a 92 grad of Clemson University in engineering. I had my own engineering company, CCAT Engineering, for almost 20 years. It was acquired about 5 years ago by Davis and Floyd here in South Carolina. I invented the Marlee Float Skimmer in 2013, and I am a licensed professional engineer, South Carolina, North Carolina, and Georgia, and was practicing that until just February this year. Now I'm doing some other consulting work out in addition to Rymar. But we're going to have, like I said, the skimmer sediment basin design webinar today. Our objectives are going to be first just to understand basic skimmer basin design based on volume for sediment basins. Then we're going to start looking at some things you may have not looked at. We're going to look at skimmers for permanent use. We're going to talk about how you would model a skimmer in hydroflow for permanent use. We'll talk about water quality design, you know, how we typically do it today with detention basins, at least in most areas, versus a new technology we have, this filter base. And then the last thing we're going to do is we're going to introduce Digital Sightbox, which is a new product that Rymar is helping to launch. So first thing we're going to do, I'm going to ask you to participate. And so just to kind of help me, how familiar are you with skimmers? You should have a poll that just gets launched, and you can just check your answer real quick. Looks like we got most are in the familiar but want to learn. Some are pretty familiar. Got everybody ours answered. So we'll end the poll. So only 10% are new, 9%, about half are somewhat new, but want to learn some more. Under 40% very familiar. So thank you for that information. Oops. So skimmers are used to meet the surface withdrawal requirements for sediment basin. They are designed to float and withdraw water from the surface of the pond. The Marlee Float's a little bit different. It takes in water just below the surface of the pond, has a debris guard that helps to trap sediment and keep it from, or floating debris from getting to the orifice. There are a variety of skimmers out there. Most of you are probably familiar with the Faircloth skimmer. Mr. Warren Faircloth started skimmers about 20 years ago out of North Carolina, and is very popular in the market. You got the erosion supply skimmer, which is kind of a similar to the Faircloth design. The Marlee Float, a little bit different, product. It looks a little different than most other skimmers. And then the IAS skimmer. So one thing that we want to focus on is that skimmers are not all equal. There's TRI Environmental did some testing for Georgia, and they tested 3 different skimmers, type 2, type 1, type 3. This chart's from their test report. Their test tank's 4 feet deep, so it goes from 1 foot to 4 feet. And what you'll see is 2 of the skimmers had similar flow rates at 1 foot depth. They were both around 37 GPM, but one was nearly double at 70 GPM. All 3 of the skimmers had an increase in flow from 1 foot to 4 feet of depth of about 25%. So although skimmers are relatively constant head, they're not necessarily constant flow, and they do have a flow rate curve to them. And again, 2 were similar, just either side of 50 GPM, but one again was almost double at 90 GPM. So the main point here is recognize that skimmers, a 3-inch skimmer is not a 3-inch skimmer. It may vary, and if you just spec a 3-inch skimmer, you may get, and you meant to get the 90 GPM, you may get the 50. If you meant to get the 50, you may get the 90. So important to specify flow rate. So one more little quick poll here, just to help me out. We had a wide variety of people sign up for this, and I'd like to just have an idea of where you're based, if I can get the poll to work. So I'm going to launch this one real quick. And if you could just tell me, what part of the country you're from. It looks like we got a heavy South Carolina contingency and Ohio, and then a couple in Georgia and Texas and a few others. So appreciate you sharing those results and answering that quickly. All right, so we've got a lot of South Carolina, Ohio in here, and a few others. So the standards do vary for sediment basins across states. This little chart just is not necessarily intended for you to provide design guidance, just mainly intended to show the differences. So there's some differences and some similarities. So basin volume, South Carolina has a higher volume of 3,600 cubic feet per acre, and they want that based on the total area going to the basin. North Carolina is about half that at 1,800 cubic feet, and they only want you to base that on the disturbed acre going to the basin. Georgia is also 1,800. Ohio is 1,800. Ohio has an additional 1,000 cubic feet that they want for sediment storage, and this is below the invert, so basically a permanent pool. And then Kentucky's over here on the right. They make you calculate everything, so I just have that on there just for reference. If we have any folks that do stuff in Kentucky, you have a lot more calculations to do. Surface area, you have two different formulas. One's 325 square feet per CFS for a 10-year storm. Georgia has an area that's related to the 2-year storm. If you run the math, they come out pretty similar. Ohio just says don't go too deep. They want a maximum depth of 5 feet. Principal spillway, that's going to be typically your skimmer and riser. Most of the time during construction, you don't have any other orifices in your riser. So it varies 2-year to 10-year storms, typical there. Emergency spillway, again, you have an overflow for your basin. South Carolina wants that 100-year managed. Other states are 10 or 25. Where skimmers are required, the typical is around 10 acres. North Carolina wants it on 1 acre or even smaller. Georgia is just preferred. What we do find is that most MS4s, if you have an outlet structure, if you're not doing a sediment trap with a rock check dam outlet, that they do want you to have a skimmer installed with an outlet structure, regardless whatever size it is. And then last key factor here is dewatering time. 2 to 5 days seems to be the general standard we see most often. Georgia has no standard, leaves it totally up to the engineer, which as an engineer I appreciate. Ohio's 2 to 7 days. And again, Kentucky makes you trap it and show, or makes you calculate it and show you're meeting 80%. Again, these are state standards. Local MS4s and even DOTs may have slightly different standards. This is just intended to give you a kind of feel for what's out there. We are seeing more states now incorporate something like this in their design manual. So this is out of South Carolina's DHEC sediment basin standards. Only thing I want to point here is this last sentence. Orifice size and associated flow rates are product specific. It should be based off product specific testing. For a long time, skimmers were based on an orifice equation, and the testing that Georgia did showed that's not exactly accurate. Again, we're trying to meet a 2 to 3 day drain range time here, so not a big deal, but it can make a difference. So we do recommend that you try to utilize testing results for flow rates, not orifice equations. So to help with that, we have a design tool that's available on our website. This is free to download, no sign up, anything required. It's a simple Excel tool. So it's going to give you a chart here on the top left with your information for your project and yourself, your basin description. We've added this check right here. This is for your required dewatering volume. So you're going to put in the area for that's going to your basin, and you're going to put in the volume required. So 3,600 cubic feet, this would be for South Carolina. If it's one of those others has 1,800 cubic feet, put that in there. Then here you're going to put in your range of time to drain, so a maximum and minimum. So 2 to 5 days, again, is pretty typical. Your pond depth. Now your depth is going to be the depth it takes to meet your volume. If your basin is 5, 6, 8 feet deep, and you meet your volume at 2 or 3 feet, you want to put 2 or 3 feet here as your pond depth. Top length and width and bottom length and width. We recognize there's very few, if any, square or rectangular basins. So use your engineering judgment, adjust these numbers. It'll calculate your pond volume for you. And what you want to do is try to get it within roughly 5% of this required volume. I wouldn't spend all day going back and forth and try to get to 201.23 feet to try to hit it exact. But again, we're trying to hit a 2 or 3 day range here. So once you have that, it'll calculate the flow for each of our skimmers with each orifice configuration. And down here at the bottom of the page, there's a skimmer report tab. You click on that, and it'll take you to a nice, neat 8.5 by 11 printout that you can put in your SWIP report or put on your plan sheet. Top portion of this is going to have your input information. So it's going to have your check here for your required dewatering volume. That is kind of a pet peeve we've seen of some regulatory folks. And this really helps to verify, yes, we size the skimmer on required, not necessarily provided. It's going to give your minimum flow rate based on your maximum time, your maximum flow rate based on your minimum time. And then because it is our tool, we're going to give you the drawdown time for every one of our skimmers with every orifice configuration. And then based on the time range you set, it's going to tell you which one of those is suitable. And so it's going to and give you the time for each one. So we typically recommend shooting for like a 72-hour time frame. That seems to be the most common out there. Some states want a minimum 2 days. So in this case, you could go up here to your 6-inch skimmer with a 4-inch orifice and drain in just over 2. I'd probably go with the 4-inch skimmer with a 3.5-inch orifice. That'll save the contractor a little money and hit that 3-day time. If you really want to save money and go all the way up to the 3-inch with a 3-inch orifice and get it drained in just under 5 days, which does meet the requirements. So we have sediment basin details also available on our website. So there's 4 different sediment basin details. We have 2 that are for temporary basins. So basically without a riser structure, just a pipe going through the dam, has the skimmer in there, has your design criteria here on the left-hand side, and your length to width ratios, your volume required, surface area, and here's where you set your minimum and maximum dewatering times. So you're in this case 2 to 5 days, but you change that to whatever your standard is for your area. And then down at the bottom is your data block. So set up for multiple basins, you can extend this. So you've got your drainage area and disturbed area. Sometimes those are different. Your flow rate, whether it's the 10-year, 2-year storm, whatever is required in your area. Basin volume, again, required and provided. Now, provided's often going to be a lot larger than required. If your basin's going to be a permanent detention pond, actually, fast forward to this detail. So this, would have a riser structure in it. And so you may be going to convert your sediment basin to a permanent pond later. So your dewatering volume may be, 3 times, 5 times, 10 times, whatever your required is. This is your basic basin information, bottom, outlet, barrel size, top of riser, spillway, etc. And then you get over here to the skimmer information. So you got your skimmer size, orifice diameter, the type. Again, it's our details. We filled that in for you as the Marlee. Is an equal allowed, yes or no? Recognize most of the time that's going to be yes, that you'll allow an equal to go in. And then here's really important, put in your flow rate range. If your flow rate is approved as a range, and contractor says, hey, I've got this skimmer from this other job, I'd like to use it, is that okay? You simply say, well, what is it? What's the flow rate? And if it falls within the range, it should be a simple shop drawing to allow that. This detail is our detail with a riser with a permanent pool. We also have one with a riser, but that's a dry basin. And then finally, our details are available there as well. So this is the 4-inch skimmer detail, but it's pretty typical. Couple of things to point out. All of our details have a block here at the top. Now you can't read that on that screen, but it shows the flow rate based on our testing from a third party from 0.1 to 4 feet of depth. Our skimmers come with an orifice plate. The plates have standard size orifices in them. We'll talk about that later at the end of the presentation. That helps you change the size very easily. We provide a flexible coupling that is similar to like a Fernco, if you're familiar with that, with a bellows. The advantage there is that it holds the skimmer in place pretty well. And then the other thing to point out is your barrel pipe between your outlet structure and your skimmer. We want that to typically be about 1.4 to 1.5 times the height of your riser structure. And we like to have a minimum of 8 feet. That just kind of gives a little length here, gets the skimmer away from the outlet, and allows the skimmer to float up easily, keeps this coupling at about a 45-degree angle at max. The coupling will bend well over 90 degrees, but that just makes it comfortable for it. And then that's just a blow up of our flow rates. A little easier to read, still a little fuzzy there. So other thing that I want to do is just show you a couple of pictures of some skimmer installs, some good and some bad. So this is a pretty good one. This is obviously a fresh basin. It's got the baffle in. They've tracked the sides. Obviously, it's very new. There's not much sediment built up there yet or any grass grown. The one negative on this one is this stone pad. They have put this in once they graded, and they didn't grade for a depression. And so what's going to happen here is you're always going to have 6 to 8 inches of water sitting in this pond. Could be a mosquito concern, depending on the infiltration rate or evaporation rate, but it's going to be really hard to get any kind of vegetation established there just because it's going to stay wet. So we do recommend putting a depression in so that you get as much drained out of the pond as possible. This one is one of the worst installs we've ever seen. So this was from an inspector, I believe, in Ohio. They didn't put a flexible coupling in, as best I can tell. Obviously, the pipe's way too short. Typically, with skimmers, you don't have to put that stone check dam in. You're going to be withdrawing from the surface, so the stone check dam's not as much of an issue. So they could have saved some money with that. And if you look close, they left the valve on this side open, so all the water's probably bypassing anyway. So really bad example of it, or bad installation. This one's not too good either. This one didn't put the right length of pipe, and they installed the skimmer upside down. Now they've got such a short pipe in here, it's probably going to drain out pretty well anyway, because the skimmer's not going to float at all. But contractors, I don't know how many contractors we have on today, but sometimes contractors do contractor things, and we try hard to make it simple, but they're not always right. Last point about this is maintenance. Skimmers are not maintenance free. They do require checking on them. All of the skimmers are going to have some potential to get clogged eventually, depending how much trash debris is in there. But in this case, if you see vegetation growing out of the skimmer, there's probably something that needs to be done. So you can see this one's got a bunch of sediment built up in the pond, so the pipe's sticking up a little bit, but actually had a huge root ball actually growing within that skimmer. So that's the quick version on basic sediment basin design and basics on skimmers. We're going to move now into talking about permanent use of skimmers. So if anybody has any quick questions on what we've gone through so far, let me know, but feel free to unmute and ask. So another question for you. Again, my polls keep disappearing. So this is, have you ever considered using a skimmer for permanent use? So if you could answer that really quick, just so I know what to think about here. Awesome. We have quite a few that actually have, so that's great. That's actually a little bit unusual. Most people usually say no. Got most people responding. So we got half say no, a quarter say considered, and a quarter say yes. That's awesome. I'm glad to hear that you have done it. So we'll do that, share results, and real quick, and then stop sharing and go back. All right. So first thing we're going to do is talk about traditional basins versus why you would use a skimmer. So typically this is a pretty good picture, right? You've got a slope down to your riser structure, and you're taking, traditionally you've got a low flow orifice at the very bottom of the pond. And so that's where sediment's going to accumulate, right? So all of our ponds are typically based on settling to meet our water quality. And so it doesn't make a lot of sense to use a skimmer during construction and then put in this low flow orifice, remove the skimmer, put that orifice down there at the bottom for your first flush, and it often results in some sort of filter or guard need to be added to it. So if you do put a skimmer in, you're relying upon the natural settling of sediment particles as they travel from the inlet to the outlet. But the skimmer is going to float. It's going to release the cleaner water from the surface. We just talked about how it's widely accepted now for during construction, proven to be very effective, very cost-effective item. So why do we think it makes sense to take it off post-construction and then pull the water off the bottom again? So quick case study here. This is a pond. Hard to believe it, but yep, all that greenery there is a pond that was obviously not maintained for quite a long time. This was a former car dealership in Simpsonville, and not surprisingly, it got a notice of violation for failure to maintain the pond. So we actually worked with the client, removed all the vegetation, and it wouldn't drain properly. It kept holding a lot of water in the pond. We finally figured out that there was a 2-inch orifice 6 feet below the muck that had accumulated in the pond. So, you can look at this pond and say, this is the inlet, obviously, but as you come down to the other end, you had 6 feet of sediment build up because a 2-inch orifice had clogged. The county wanted all that taken out, and it was going to be very expensive to do that. So we convinced the county to do a pilot project. We put in a skimmer with a 5-inch orifice, which provided a flow rate similar to the 2-inch orifice. We modified the other orifices. So you can see here, this left picture, we filled those in and put in some higher orifices. This is one of the few ponds that had a little extra volume available. So we were able to do that without really changing the pond. And the excuse me, the county required us to monitor because this was a pilot project, so we had to monitor it monthly for the first 12 months. So here's some of our pictures during that time, and it's working pretty well, right? The skimmer's draining it down, drain it over time. Got some of these just after some rain events, so water's still there. Then in 2014, they had decided they're going to keep maintaining the pond, and so they had landscapers out there. They were cutting the sides as it was a very steep pond. So they just kind of cut it all, let it go to the bottom, and they were going to pull it all out. But they had a big rain, about 5 inches in less than 8 hours. And so all the trash got pushed down to the bottom of the basin. But you can see our skimmer sitting there, did not get clogged up, actually drained the pond down. If this had been a 2-inch orifice down here at the bottom, this picture on the right shows it, that riser structure is about 12 feet tall. And so water would have been up here, at these outlets, which is probably 7, 8 feet tall. So it would have been impossible to get to a 2-inch orifice at the bottom here. So at a minimum, the skimmer was make it much easier to maintain it. So if you're going to consider using skimmers post-construction, we need to know how we incorporate that into our model. So we're going to dive here into a pretty technical part of the presentation to talk about using the skimmer with HydroFlow hydrographs. I know there's a variety of different softwares out there, but we're going to focus on this one since it comes with Autodesk now and seems to be one of the more popular. So this is actually a real site we did in City of Greenville. We had a area of about 5.5 acres. We were developing about 2.25 acres. The other 3.4 was staying as is, going to a sediment basin here, and then it was draining across the road to an outlet. So our pre-development, again, was 5.5 acres, curve number about 59 for wooded condition, time of concentration just under 20 minutes. The post-development for the area we're disturbing was 2.25 acres. We used a curve number of 86 for basically a bare earth condition, and had a time of concentration of 7 minutes. So when you build your basin in HydroFlow, you need to put in points that you can put in the flow rate later. So in this case, we built a stage at 0, 0.1, 0.3, 0.5, and then a 1/2 foot up to 4 feet. Doing that gives us a place to put in our skimmer flow from our detail. And so then you build your outlet structure. Your culvert A is your outlet. So in this case, it had an 18-inch pipe going out. This orifice had a 6-inch, the outlet structure had a 6-inch orifice about 1.75 feet above the bottom. The riser was 3.6 feet tall and had a rectangular weir of about 0.6 feet at the top. And then here's the kind of the secret sauce magic to modeling the skimmer. HydroFlow has this user-defined column. And so you simply plug in your user-defined flow rates off of the details at each stage that you created when you built your basin. So it is a little tedious to build the basin that way, but these days you typically are offsetting 3D polylines, so it's not that hard to come up with a area at each one of these increments, and you plug that in. You'll see that the total outflow is just the user-defined flow until you get up to a 2-foot depth. That's where that 6-inch orifice kicked in, and then the riser kicks in, etc. This case, we were just 4 feet deep, so our testing results had that. If case, many basins can be more than 4 feet deep, so you can either extrapolate that out. You can use it, basically maintain the flow rate at that 4-foot depth, or maybe go slightly more. In most cases, skimmers are kind of flattening out as far as the flow rate curve at 4 feet. Or you can go back and use the original tool to calculate your flow rate. I talk about that too. If you look at the outlet structure, normally you're going to see a low flow orifice down here. And that's going to be, what you're going to use to drain your bond. This is a 6-inch orifice, rectangular weir, and riser. You don't have that low flow orifice because you're using user defined. But you look at your stage discharge, you do have some discharge starting at the bottom of the pond. So it's coming out. And this green line here, if you can see that, is your skimmer flow. So you can kind of see where the 6-inch orifice kicked in, where the rectangular weir kicked in, where the riser kicked in. So that's your outlet structure. And again, total flow is just the skimmer up to a certain point to the basically at the 1.75 foot level. And then after that, the others kick in. This case, our 2-year storm had a 2.3 CFS for our pre, 2.5 for our post. So the city let us get away with a 0.2 CFS increase. Some will, some won't. And then we had a half a CFS decrease on the other. So that is real quick how to model it in HydroFlow. I am doing some more detailed training videos that we'll be posting to our website over the next couple of weeks that I'll do a little deeper dive. So look for those if you go into modeling and have some questions or issues with that. We already answered that one exactly. I didn't put that right, but we actually wanted to ask was, based on what you learned today, would you consider skimmers for permanent use if you didn't before? So cool. Got a couple still saying no, but they should be temporary. But overall, majority are saying, yep, we'd at least think about it. So good to know we at least open your mind a little bit today. So about half said maybe, and just under 40, over 40% said yes. I'll share those results too. All right. So last thing we want to talk about is water quality and how we do water quality design. So as I mentioned, the advantage of using a skimmer is you get that surface withdrawal. So, currently we use a extended detention for water quality. So the idea is you collect that first flush, hold it for a certain period of time, drain it out slowly, and allow for settlement. And so there's some flaws with that. So one of them is that the basins are designed to capture pollutants by holding runoff for extended time, allowing for settlement. Basins that rely on settling time, they provide very little treatment for smaller storm events. Not sure about you in your area, but it hasn't rained much in South Carolina in the last few months. And when we do have rain here recently, they've been very light rains. And so those small rains are still going to wash off pollutants that have built up over time. But if it's a small rain event, you're going to get very little ponding, and that's how we get our treatment. Also, the volume-based designs result in larger pond sizes. So by doing that and having that volume in there, you end up with a big pond. So the benefits to using skimmers, and in this case, we're going to talk about adding skimmers with a filter on them, is the skimmer can be sized to control the peak rate for lower storm events. So in most cases, the 2-year storm is kind of like your storm event that you have to do your first quantity control with. If you can use the skimmer to control that as your outlet structure, then you're going to be treating all that flow. Your skimmer, again, is going to increase your filter efficiency by withdrawing from the surface where the water is cleaner. And it's going to be relatively easy to access for maintenance and changing the filter because it's just going to have a rope tied to it, pull it over to the side, or if it's a dry basin, easy to get out there and get to it. So there's some benefits to using filtration instead of settling. So number one is your ponds provide a large containment volume, so you reduce the maintenance frequency and treat large drainage areas. I'm sure many of you have used catch basin filters before for water quality. Those are good, but they have a very small volume. If you put that filter in the pond and use the filter to trap stuff in the pond, you got a much larger volume. One other big benefit is there's excellent potential to retrofit older basins that did not include water quality benefits in the design if peak flow rate can be maintained. So the idea here is size the skimmer and filter to keep up with that 2-year storm, and you don't have to try to go into an older basin and retrofit to add volume in order to meet water quality requirements. And again, we said filters are pretty easy to maintain, especially if you consider that relative to an underground vault or some other kind of specialized system. But there are some challenges. There's no doubt, it's not a perfect solution. So filters are prone to clog over time, and so there is some maintenance going to be required. Do some periodic cleaning or changing. The other thing is skimmers must be durable and last more than a few years to be suitable for permanent use, and may not be great if they are in an area that has frozen conditions. When by frozen we mean a foot or 6 inches or more of ice. One of the reasons that skimmers have probably not been considered for permanent use previously is because most skimmer models are PVC, and we all recognize that PVC is not as UV resistant and durable as a HDPE product, which is what the Marlee Float is. And the biggest challenge we have is there are no established standards for basin design and permitting based upon a combination of a pond and filtration. There are some standards out there for what they call MTDs, or mechanical treatment devices. Some areas have said they would consider the filter an MTD and do under that. There are also some other standards that are coming. If you're familiar with the STEP program that's just getting started, they're going to be looking at some filtration standards, so maybe able to use that in the coming year or so. So going back to our pond in Simpsonville, we replaced the skimmer that was out there with a prototype that we were testing for our filter. And this was one of the early prototypes. And we just had the filter right around the skimmer itself. What we found out was that the filter was not big enough to keep up with the flow rate of the skimmer and just did not function too great. So we prototyped a couple other things, and we came up with this new prototype that was installed, and it was a 2-stage system. The outer stage is just a polypropylene screen. It's a Mirify fabric. The inner is a non-woven material, and it is designed to absorb hydrocarbons. It helps with TSS. It has some benefit for metals, may even have some benefit for phosphorus, nitrogen. We're working on that. And the version we use is actually treated with an antimicrobial. So you also get some limited bacteria treatment as well. So the prototype's been regularly monitored now for over 2 years. The pond that we have it in, again, is that one that had 6 feet of muck in it. Well, it had 6 feet of muck in it because it's in an area that doesn't have much stormwater management. And so this pond gets a lot of junk. See from these photos, it's tons of debris and trash and stuff getting in this pond. So it really, really does build up. But what we have seen is that you can tell a little bit of difference even in the pond on the turbidity of the water on the outside of the filter inside. But this right picture is actually the outlet, and that, I mean, I wouldn't drink it, but it's fairly clear water coming out of there. So our filter seems to be doing a pretty good job of cleaning it up. We have since tested the skimmer, and had a third party do some lab testing, and we've gotten over 90% TSS removal, and it was tested per a relatively new ASTM standard. So TRI Environmental did the testing. They had to test two different versions of the skimmer. They did it in a tank. And what I like to point out is this is the sediment laden water coming in here. And so what we did is we took out the forebay of the pond, we took out the travel distance, we basically dumped the sediment in right at the filter and said, okay, go straight through the filters to the skimmer, let the skimmer pull them through, and let's see what happens, just based on the filter and skimmer, not to factoring in any of the benefits of the pond. And what we found was that both tests had a 90% plus TSS removal rate. One was 92%, one was 96%. And so we're very confident based on this testing. And then you put in a real world pond and add the forebay, add the travel distance, add the other benefits of a pond, you're easily going to hit that 90% rate. And so what we've done now is we've now gone back to our pond in Simpsonville, and we've installed our current skimmer. We've had some updates on it, and this is the new commercial version of the filter. So we've installed a time-lapse camera here. Hadn't rained since we put it in, so don't have any photos of that yet. But we installed that, and we're going to continue to monitor this over the next several years so we can verify the lifespan of the filter, see any issues, etc. But this is commercially available now, and we plan to start having it available. So the benefits of the filtration versus settlement is the peak rate of discharge can be based on the filter treatment rate, flow rate up to the first quantity storm event. Like I said, normally we're just treating that first flush, and the first flush event is going to be around 1.75 inches rain, 2 inches rain. A 2-year storm event may be 3.5 or 4 inches of rain. And then the filter, the benefit there is the filter treats 100% of runoff from the storms up to the peak rate of the filter. So again, if you can size the skimmer to handle your 2-year storm event, the filters are all sized to keep up with the skimmer. So you're now treating all the rainfall from your 2-year storm event down to the smallest rain event. Every drop of water has to go through the filter to get to the skimmer to get out of the pond. So you're really increasing the amount of rainfall you're treating, and you're treating it to something that's been tested. And the other benefit is with our dual stage system, the filtration media can be customized to target specific pollutants of concern. So it looks like there's a question in the chat. I'm going to read this real quick. Talking about assessing skimmers for flood improvement with detention. So I think what they're asking there is what we're going to get into here in just a second. Is the modeling of the skimmers versus the volume-based versus filtration-based. And so the skimmer is just part of your outlet structure. And so it would be modeled in just like a low flow orifice or any other orifice would be. So it's the skimmer itself is going to be focused mainly on the water quality benefit, but it's going to just function as part of your outlet. So I'm not sure if that makes sense. If that doesn't make sense, maybe ask a little different question. I'll try to answer that. So last thing we're going to talk about on our skimmers today is water quality modeling. So this is going to run through just a quick example of volume-based modeling versus filtration-based, so we can kind of show the benefits of one versus the other. So first off, your volume-based is typically that first flush, right? You release that over 24 to 48 hours in most cases, versus a filtration base, which again is just based on the flow rate of the filter. And again, you may have some quantity control requirements that limit your skimmer size, but you can get the flow rate for skimmers down pretty small. So our sample site is going to be 5 acres. We're going to again assume a wooded precondition of 55, curve number, post-development, curve number 92. So we're going from wooded to fully commercial. So first step you're going to do is based upon the 5-acre wooded site. We got a time and concentration just assumed about 48 minutes, maybe a little higher low depending on the site. but what are our pre-development flows? So our 2-year storm has a 0.72 CFS rate, 10-year 3, 25, 5.4, 100-year 10. So we're going to focus here on our 2-year storm when it comes to the skimmers. So step 2 is what's our water quality volume and what's our post-development flow rate going to be. So based upon that 5-acre site, time of concentration, we assume just 10 minutes. So my water quality storm event in our area is 1 inch of runoff from the area. So that'd be about 18,150 cubic feet. I know some other areas are 1.2 inches, or that volume may vary a little bit, but in South Carolina it's 1 inch. We based it on that. And so I went into the hydrology program, did some trial and error, and came up with a 1.73 inch 24-hour storm event that would generate 18,100 cubic feet of volume. That volume would have a flow rate off of that developed property of 7 CFS, 2-year storms all the way up to almost 20 CFS, and so on. So most places, what you do then is for your traditional design is you size that first flush orifice. So here again, a little bit of fallacy with this. We assume that first flush volume magically appears instantaneously in the basin. Now, we all know that doesn't happen. It comes in over time based on the storm event. But for sizing this, we go, okay, we've got 18,150 cubic feet. Got to come up with what orifice would drain that volume over 24 hours. It's a calculation here on this spreadsheet that factors in head and et cetera. And it came up with a 0.21 feet or 2.6 inch orifice. So hard to make a 2.6 inch orifice. So I came up with a 3-inch orifice, plugged that into the program. So we got a 3-inch low flow orifice down here with a trash guard. That's at an elevation of 110. Had another 3-inch orifice at 113 to control by a 2-year storm, and an 8-inch orifice at 115 to control the 10-year storm, and then a riser at 117 controlling the 100-year storm or 25-year storm. And so what we see here, remember our water quality volume is 18,150 cubic feet, and it came up to an elevation of 113, so basically 3-foot depth in my pond. My actual water quality volume that I need to run that storm event is 10,700 cubic feet, and it only comes up to 12.5 feet of elevation, or 112.5. So we've got an extra 1/2 foot of volume in here that we're really not needing for our water quality, but based under the typical standards, we have to hold that. 2-year storm was released at a 0.81. Again, it was 0.72 before. I'm assuming we might get away with a 0.1 CFS increase. Depending on the reviewer, we may not, so we have to tweak that a little bit, but that's the calculations. And then this was our storage required for each storm event based on running through the model. So now let's look at the option of let's use a skimmer with a filter. And so I said, okay, let's look at the peak flow rate for the different skimmers. And our 6-inch skimmer with a 6-inch orifice has a 0.77 CFS flow rate, and that's at 4 feet of depth. Remember, our water quality volume is only getting about 2.5 feet deep. And so let's run that. You'll see if that'll work through the model. So we've modeled that in there. Then we have to do our filter for a 6-inch skimmer. This is the detail for the filter. Again, there's 2 versions. We have an outer skirt, an inner skirt. The outer skirt is this Mirify woven geotextile. The inner skirt is this absorbent panel. And if you look up here, 6-inch skimmer, the inner skirt is going to be 8 by 16. So it's going to be 8 feet this way, 16 feet this way. Our outer skirt is going to be 20 by 10. So 20 feet this direction, 10 feet this direction. Now, why do we do that? Because remember, this pipe's going to come up at a 45-degree angle. So our skimmer is going to get closer to the outlet structure as it rises. So if we went 20 feet this way, we're going to have a problem because we're going to end up hitting it. In this scenario, it's a total of 10 feet of length. So it's really only 5 feet from the skimmer to this side. So if we have our, at least 10-foot length of pipe, the outlet, this filter is not going to hit the outlet structure. And then this was our pond detail. You may recall in some of our previous details, we showed the skimmer to the side. we did that in temporary basins because it's just easier to get to maintain and kind of check for clogging. For a permanent condition, you're definitely going to want to stick it, out in the pond so that the filter has room and it's not bumping up against the sides. You may have a dry pond, may have a wet pond. We've got this, detail for dry basin or wet basin with all your basic information here that you would have and need for that. And so if we model this back through the same hydrology program, and we've plugged in our 6-inch skimmer flow rates like we did in HydroFlow, I showed that previously, you're going to have a peak flow rate now for your water quality event of 0.7 CFS and a peak elevation of 12 feet. So now, and we're only using 7,600 cubic feet of volume. So our volume requirement went from 18,000 cubic feet to 7,600 cubic feet. And we've got an extra foot in our pond that we can now work with to contain our other storm events. The 2-year storm is 0.78, so we're detaining it. And then this configuration, we had our skimmer down here at the bottom, then an 8-inch orifice at 114.8, and we're actually able to lower our riser a half a foot. So our pond got a little bit shallower as well. And so if you look at the analysis of with the skimmer versus traditional, you can see how much storage is required for the skimmer version versus storage required for the traditional. And if you run the math on that, it's about a 30% decrease in volume for your water quality event and 12 to 14% on the rest. So if anyone out there has a client that says they would prefer to have a bigger pond, let me know, but I haven't found one of those yet. So you're getting the benefit through this method of a smaller pond. And again, we're treating a larger amount of the rainfall and treating those small rain events. So it's a win all the way around to use this method. So any questions on any of the technical stuff we've got into? We're going to wrap up this with just a little bit of information on our website and then introduce Digital Sightbox to you. Don't see any other questions in chat. Matthew, thanks for hanging out. Yeah, we'll make the recording available to you. All right. So mention our website. This is our website. It's rymarwaterworks.com. We've intended this to be very, very useful for you. We just made a major update. So before we used to have individual downloads of all of our information. Now we've made it really simple. We've got one, and we're calling it our engineers pack. And so it's a simple zip file. One download, you unzip it, it puts it in all kind of folders for you. Within that, you're going to have the Marlee Float Skimmer details, sediment basin details, water quality basin details. I included a little README text in there just in case you have any questions. But for the skimmer, you're going to get CAD and PDF of every skimmer. You're going to get our skimmer testing, so you can confirm our third-party flow rates. The flow rate chart. A lot of times you're required to provide maintenance information. We've got that. And then we've got our 2 design tools, one for a standard dry pond and one for a permanent pool. The sediment basin details, we show those. You're going to have your skimmer and all 4 versions in CAD and PDF. So you can have a skimmer and riser wet pond, skimmer and riser dry, and then the wet and dry temporary. And then finally, our water quality basin details. You're going to have a dry and wet basin. You're going to have the filter detail. And then you're going to have the test data on the absorbent fabric. That's the internal, the inner skirt. We have not tested that with the skimmer yet, but we thought it was good to see the benefits that material has. We have a design guide in there just to kind of walk you through the steps, maintenance recommendations, and very important, our test report to the ASTM standard confirming 90% TSS removal. So in most cases, when you submit your SWIP, especially until this gets widely accepted, you're going to need to let your reviewers know that this has been third-party tested, does meet the ASTM standard for that. Again, been through our detail. I won't go back over it again, but all that information is there for you. The product itself, it is made of HDPE. It's got a polyethylene float, and all of our fittings are either stainless steel or aluminum. We call it UV resistant. Well, it is UV resistant. We call it virtually indestructible. I'm sure somebody could beat on it and tear it up if they tried, but it's very durable product. And we intended this from the beginning for it to be part of the permanent outlet structure. And there's really no moving parts. You got one part that pivots, so it's really nothing to get stuck or break. Again, we have this debris guard around it, so water has to come below it, so it keeps the floatables away from the orifice to reduce clogging. Our outlet is below the surface, so it will continue to work in mild frozen conditions. And the only thing that touches the mud is the bottom of a round pipe, so it doesn't get stuck. I honestly say I've never heard of an instance where our skimmer has gotten stuck in the mud. Mention our orifice plates. This little quick video to show how that works. So again, it's just a little rubber plate. You twist it, and we have this little metal nub in the center here to make sure that the orifice gets centered. See, it's right on the orifice, perfectly centered there. And so really simple for contractors to change the flow rate and change the size. And each one of our skimmers comes with 3 to 5 different flow rates per device, and all have been third-party tested to verify the drain times. Some of you may have seen the Marlee Float back from several years ago. We changed the design about 3 years. Original design was a little top heavy, tended to tip over if it wasn't installed correctly. We went through an extensive prototyping testing process and developing this new one. This is our man Aaron, who is our shop manager. And, put him in the tank with the skimmer, and hopefully that never happens in the field. But you can see it always floats, always stays level. Done a lot of testing to make sure that the product is really solid and designed for permanent use. Our 6 and 8 inch versions have handles around the float now. They're pretty heavy. They weigh about 200 pounds because we're trying to hold a 6 inch or 8 inch pipe below the surface. And once that pipe gets up at a 45-degree angle, there's a lot of buoyant force in that pipe. And so the skimmers have to be very heavy to keep that pipe down. Also need a big float to make sure we stay floating when the pipe's full of water. We have 6 different versions. We go down to our 2 inch with a 1/2 inch orifice, which flow rate is only 250 cubic feet per day, which is just a trickle. Our standard 8 inch uses a 6 inch pipe to connect the 8 inch skimmer to the riser structure. The flow rate there is 1.5 CFS. Most other competitors' flow rate for an 8 inch is around 0.9 to 1 CFS. And then we have our 8 inch with an 8 inch pipe. We sometimes refer to that as our 8 inch max. And it has a flow rate of almost 1.8 CFS, which is about double what most other 8 inch skimmers flow. So if you have a really large site needing multiple skimmers, our 8 inch with 8 inch pipe can be very effective. The cost for it is just slightly more than a competitor's 8 inch skimmer. So you're basically getting a 2-for-1. For those of you that use HydroCAD, the skimmer is incorporated into HydroCAD for modeling. We didn't touch on that today, but we will have a video up about how to model it in HydroCAD coming soon. So if you're interested in that, keep an eye on that, or just shoot us an email. We'll be glad to get you that information. That's going to end the skimmer portion of this. Looks like we're doing pretty good on time. Got about 5 minutes left. And so the last thing we want to talk about today is introduce a brand new product to you. So this product is called Digital Sightbox. And Digital Sightbox is intended to replace the on-site job box with a simple sign with a QR code. Right? So we've all experienced issues with these on-site job boxes. As an engineer, how many times have you had to replace plans, replace the SWIP because they got wet, the post fell down, box fell off the post, or whatever it may be, or just ran out of room? So they've got limited capacity. They're not really an effective communication tool, right? Stuff gets stuffed in these boxes. You're not sure when it got put in, who put it there, what's going on. A lot of times it's missing. You don't have any remote access, obviously, to it because it's just hard copies. And it's, often you have trouble keeping it up to date with the most relevant plans. And so Digital Sightbox is a cloud-based software. It's a simple website, so there's no app to download or software to download. It's basically a storage for your plans, for your SWIP, for your inspection, etc. It's got a messaging feature, and it's digital, so it's accessible from anywhere. If you're on site, you simply scan the QR code and it'll take you directly to that project, or you can get on from your computer or device otherwise and get it in. Got a rain log that's automatically built into it based off the latitude and longitude used to set it up. So you've got easy document sharing. You got access full time. It's very cost effective, $150 or so per site or less per year. And that's what it looks like in the field. Just a simple sign, weatherproof sign with a QR code. Once you log in, set up your projects, you've got all your projects in one place. You've got all that information. You can manage your users. You can use your lat long again. You'll have a rain gauge. If you need to secure certain folders or subfolders, you can create a secure pin. What we've seen is like some of our home builders love the use of the digital for plans and stormwater reports, but they will also want to have their on-site staff have their building plans there. Well, ABC builder doesn't necessarily want to share their building plans with the XYZ builder. So having that lockable has been an important feature. The rain gauge is powered by NOAA. We actually are working on an on-site version as well. So it'll actually have an add-on feature. If you need an on-site rain gauge, that'll electronically measure rain and track that. That'll be coming out in the next few months. You can upload documents, basically any kind, are supported. And we have a built-in PDF viewer. So if you upload PDFs, you can view those through the website portal. It has messaging, so you can send messages to your team. It also date stamps anytime someone uploads, views, or downloads a document. So you can see who's been in the site box, who's looking at what. And like I said, you can secure it with a PIN code. We also offer custom signage. So if you want to have this as an additional marketing piece, we can customize signs, colors, etc. For you as part of the package. Our pricing, like I said, is very cost effective. The basic starts at 10 sites. We can go a little less than 10 if necessary. We like to start it with a package of 10 just for efficiency of getting signs to you. And that's $150 per site. If you go over 50 sites, the price drops down to $100 per site. And if you go over 100 sites, then you're up in our premium version and the price drops down to $75 a site. And that cost is an annual cost, just annually renewable. So that's for the entire year, you're only paying that. If you compare that to what a job box costs when you factor in the cost of the box itself, cost of the plans, cost of the SWIP, cost of the time to print the plans, bind the plans, deliver the plans, it's much more cost-effective solution. So that's just getting launched. We have North Carolina, South Carolina, Georgia approval on that. Ohio, we just about have approval there. Kentucky, we're working on. Tennessee, we actually have a meeting this afternoon with the state of Tennessee and multiple municipalities to go over it with Tennessee. And we'll be expanding to other states as well. So if you have questions on Digital Sitebox and is it ready yet for your area, please don't hesitate to reach out to us. Or if you just say, hey, we would love to use this, then we can make sure to prioritize your location. So it looks like we got one other question in the chat. I'm reading your question real quick. Let's see. Got it. All right. So Mario said, yeah, Digital Sitebox is accepted in his area. He's in Easley, South Carolina. And maintenance issues. So you do have, if you go back to our filter idea, that is something that you need to, as an engineer consultant, look at your local MS4's design manual, talk with them about it. We're still getting that out. We're working on state approvals and getting to the MS4s. Most of them have said they would consider on a case-by-case basis. I don't think we have any that have said they would not allow it. The only one that is concerned about it is I know we had a good South Carolina contingent on here. So Greenville County, for residential projects, they don't like any mechanical treatment devices. So they said they would consider the filter an MTD and don't want to see it on residential, but would consider it for commercial. But it is something that's going to require some maintenance. It's not a perfect solution, but there's not a pond out there, as I showed in the case study earlier, that doesn't require some maintenance. So it's just making sure your clients and your projects understand what they're going to have to do once the site's stabilized and the contractors have left. So that's it. We actually hit our time almost perfect. Don't do that often, but glad it worked out today. Thanks everyone that participated. If you would like to have continuing education credit, please email us at info@rymarwaterworks.com. We should have a list of who all was on here. Not sure who's a PE and who's not, and who needs a PDH certificate. More than happy to get that out to you. And final thing here, we are going to do a drawing from all the participants, and we're going to be sending out one $50 gift card to help you with your either Thanksgiving or Christmas this year. Really appreciate everyone joining in, and we'll send out a notice on who was the lucky winner of that once we do the drawing. But it'll just be a random drawing from all the names that for everybody that participated today. So if anybody has any questions, I'll be glad to answer. Otherwise, we hope everyone has a great day and great holiday season coming up. All right. Not hearing any, we'll let everybody get back to work. And thank you for your time.